Hello everyone. Today we're going to be talking about Newton's second law. So this is the law of mass and acceleration. So his law is that when a force acts on a mass, acceleration is produced. So this is the idea that if an object, according to our previous example, an object at rest will stay at rest, an object in motion will stay in motion. For an object to accelerate, for that motion to change from whatever it is to some to something else, you must act upon it with a force, and that force will be acting on the mass of the object. The greater the mass, the greater the amount of force needed to cause acceleration. So force and mass are proportional to each other, and force and acceleration are proportional. So this is the idea that force is proportional to acceleration. Force required to produce acceleration is also proportional to mass. So there's some sort of relationship between force and mass. The second law of motion explains the relationship between an object's mass and the acceleration it experiences due to a force. Remember that mass is the amount of matter an object has. It tells us that the more mass an object has, the more difficult it becomes to start, stop, or change the object's motion. For example, it takes a great effort to push a piano across a room, but a piano bench will slide considerably easier. This is because the piano has a greater mass than the bench. A larger force must be applied to the piano in order to accelerate from rest. Newton's second law also applies to sports. Consider how easy it is for a batter to send a baseball soaring through the air because the ball has a small mass. Even a gentle underhand toss will accelerate it from rest. Can you imagine tossing a bowling ball with the same results as the baseball? The added mass makes it impossible. And we can extend that to something like ping pong, where the ping pong ball has as little mass as possible, so that the small actions of the ping pong ball player can cause very quick accelerations of the ball. Now, by the same token, even the small amount of force of air resistance on the ping pong ball can also cause a drastic change in acceleration. So a ping pong ball flying through the air will likely slow down very quickly because of the force of the air on the ping pong ball. Meanwhile, the force of the air on a bowling ball will not be able to slow down the bowling ball nearly as fast because the bowling ball has so much mass, it requires a greater force acting on the bowling ball to slow it down. So force equals mass times acceleration, or F equals ma. And one thing to consider is that if F equals ma, then we could also write F divided by mass is equal to acceleration, or that the force divided by acceleration is equal to mass. So these are the sort of three permutations of this equation, which can be useful when you're trying to solve different things. Some teachers and some students find that it's helpful to use what is known as a formula triangle, like this. So if you draw a formula triangle where you put the force at the top of the triangle, and let me write, thank you. Okay, you put a force at the top of the triangle divided by m and a. Now, if you have a question that asks you to determine a force, what you're going to do is take your thumb. I'm going to just draw my thumb as a sort of black spot here. So if I take my thumb and put it over force, which is what I want, it's mass times acceleration. If I want to know the mass, I cover up the mass in my triangle, and I know that the equation is force divided by acceleration. If I want to determine the acceleration, I simply cover up acceleration, and I get the formula force divided by mass. I'll go over this again when we need this equation later. So here is a minivan where a force of 6,000 newtons is being applied to the minivan. and that force is being applied to the right. This minivan weighs about 2,000 kilograms, so we can use Newton's law to determine how fast the minivan is accelerating. Here, the force is equal to mass times acceleration. So, looking at my minivan equation here, I'm looking to understand acceleration. So I cover up acceleration, and I realize that force divided by mass will give me acceleration. Acceleration equals force divided by mass. So acceleration equals force divided by mass. So if I take the 6,000 Newton force and I divide that by the 2,000 kilograms, I will get an acceleration of 3 meters per second squared. So the minivan is accelerating 3 meters per second squared when its engine applies a force of 6,000 newtons to the van. It does not mention anything about how fast the minivan is going already. It could be going, it could be stopped, and it could be accelerating from stop, or it might be accelerating from a current speed. Either way, you're still going to apply that 6,000 newtons to the van in order to get it to accelerate at 3 meters per second. Now, you notice that I got the units of meters per second squared. Well, that's because when you divide a newton by a kilogram, you can convert the newtons into the units of kilogram meters per second squared. And then if you're dividing that by kilograms, the 2 kilograms will cancel, and you are left with only the meters squared. So a newton is equal to a kilogram meter squared. Mass times an acceleration is the unit of force, the newton. And so therefore, when we divide a newton by a kilogram, you end up with the simple meters per second squared at the end. Okay, so let's check our understanding. Let's see if we can understand some of these thought questions. So explain why a person wearing a cast on one leg becomes more tired than usual by the end of the day. Well, one idea here is that they still need to move their mass around, right? So they still require the same amount of force, but that same amount of force has to come from one leg instead of coming from 2 legs. And also they have the additional weight of the cast. So they still need to move. They still need the same amount of force to move their mass of force to move their body's mass but now one leg must provide all of this force. So the leg gets tired, more tired. Suggest a reason why large vehicles such as vans and trucks tend to have larger engines and higher rates of fuel consumption. Well, larger vehicles have more mass. So they need to put in more force to get the same acceleration. This is why the Mini Cooper for a couple of years was really tearing up the way in the open car races, because the Mini Cooper was such a small, light car, even though it wasn't really intended as a racing car at first. At least that's my impression. It was such a light car that when they put in a nice big engine into that little tiny body, it took off and was able to zip around those tracks. Um, Also, if you look at any racing car whatsoever, weight is a huge issue in those cars, and they spend a lot of effort in trying to reduce the weight of every item inside the car. Even the spaceships are all made out of materials that have to be as light as possible, so that they can carry so that they can be ejected from space into space with the amount of force that they can put out. Use Newton's laws to explain why people in a car often get neck injuries like whiplash when struck from behind. So when struck from behind, the head continues to move. When a car is hit, the acceleration on the car is different than on the head. So they move separately, causing injury. I'm going to just convert this a little bit to some text for leaving it behind. Okay, so why are small rabbits often able to escape bigger and faster bobcats in pursuit by zigzagging as they run? The smaller animal requires less force to change acceleration, and therefore change direction. So every time you change direction, it's a change of acceleration. They get less tired zigzagging than the larger predators. And this is also true for small children. I know my son, he can out zigzag me, even though he's a little tiny baby. He can run around and change directions real fast because he's got a little tiny mass, and I'm trying to thump around after him. So that's definitely the case. And then I get tired, and I'm always wondering, why am I so tired when I'm playing with my kids? And they're little, they have little mass. They have a lot of energy, and that energy is very easily converted into changes in acceleration, whereas my larger mass takes lots of energy to change acceleration on. Predict when serious injuries are more likely to occur: when a car crashes into a tree or into a wooden fence. Well, the tree will not change, will likely not bend under the force of the crash. So the acceleration will be very quick. The deceleration, I should say, in the car versus the crashing into a fence. The deceleration will be slower. Faster deceleration equals higher force on the bodies of the drivers, of the passengers. So this can be a tricky one to think about, but when you're hitting a car against a tree, there's going to be the tree is not going to change acceleration at all. It's going to stay in place. So all of the change of acceleration is going to happen in the car as it takes in all of that force to very rapidly slow down, because it essentially is going to hit zero acceleration as it hits the tree, and that's going to happen almost instantaneously. That means a very fast deceleration. Fast deceleration means high force for everybody involved. When a car hits a fence and the fence slowly falls over and the car keeps kind of sliding forward over that fence, that will be a longer period of time that the car is decelerating over. So that's a slower deceleration. Slower deceleration equals a smaller deceleration will mean that a smaller force is involved, even if it's the same mass in both cases. So what we're using this equation, force equals mass times acceleration, we're saying that if we bring down the acceleration, we actually bring down the force. So that's why you want to accelerate slowly. This is one of the things that your airbag is doing, is it is actually influencing the acceleration. It's trying to provide a cushion so that your head slowly or more slowly hits the steering wheel, as opposed to just slamming right into it and the acceleration being quick. Anyways, that's the ideas. Please investigate more about this force equals mass times acceleration with maybe one of the interactives that I posted, or possibly some of the other videos in our playlist. And have yourselves a great day.